Well, good afternoon, good morning, or good evening, depending upon where you are in the world, and welcome to today's DevOps.com webinar. I'm Charlene O'Hanlon, moderator for the event, and I welcome you. We have a really fascinating webinar on tap, but before we get started, we do have a few housekeeping items we need to go over. First of all, today's event is being recorded, so if you miss any or all of it, just know you'll be able to access the webinar on demand. We'll be sending out an email that contains a link to the webinar. Should be hitting your inbox probably around an hour or so after the webinar. And we are taking questions from the audience. So if at any time you have a question for our panelists, don't wait, just use your GoToWebinar control panel and submit your questions. And we'll take probably about 10 or 15 minutes near the end of the presentation and go through those questions. Okay, with that, we'll go ahead and get kicked off with today's webinar, How to Transform IT Operations with Machine Learning, Apply Context. Our speakers today are Leslie Minnix-Wolfe, who is Senior Director of Product Marketing at ScienceLogic, and she's going to be joined by Charles Araujo, who is Principal Analyst at Intellyx. Welcome, Leslie and Charles. Thanks for joining me today.
Good to be here.
Great, great. Well, Charles, I know you're going to get things going for us, so I'm just going to let you do your thing.
Thanks. So if you're a little bit on the older side like me, you perhaps remember a movie from the mid-90s called Jerry Maguire. Now, it had a couple of scenes that were very, very memorable, but one in particular was truly iconic. So iconic, in fact, that no less than 2 US presidents have actually referenced this line from this movie in public speeches. So I'm curious, if you are listening here live and you think you know what this line is, go ahead and put it in the chat box. I think this was going to work. I'm just curious to see who knows what I'm about to say. But in this scene, Jerry Maguire, played by Tom Cruise, is sitting there. He's an agent down on his luck, and he's trying to keep one of his last clients on board. And in this, played by Cuba Gooding Jr., there, he's just going at it, and he's not happy with this contract. And he's telling Jerry Maguire that he needs more money. He starts screaming. That's right, somebody got it. Show me the money. But more than just screaming, show me the money, he made Jerry scream it. And there's this scene with Jerry sitting in his office, sitting at his desk, just screaming at the top of his lungs, show me the money. And I don't know about you, but I sort of related to it because when I was in IT, so we didn't get through kind of my whole background here, but I ran for about 20 years ago, I ran technical operations for about $1 billion healthcare firm. And I remember at the time, there you go. I remember at the time that my management was all over me. It's like, we need data. And it was like almost that scene playing out, show me the data. They wanted me to produce data so that I wasn't just managing kind of this hero culture just by the seat of my pants. They wanted it to be done in a way that made sense. And so, you know what? We dove in. We all did it. And in the 20 years since, I've mostly been on the buy side advising enterprise executives as they went through this transformative journey. And this was one of the recurring themes. Show me the data. And so you know what? We did it. We instrumented everything, and we've been doing it that way ever since. And in fact, it really goes all the way back even beyond IT to Peter Drucker with this famous statement that said, you cannot manage what you do not measure. And so we have measured everything. We have collected data on everything. The problem is that all of that data has really not done a great job of helping us do, I mean, it did at the beginning, but as we've collected more and more data, that data has just turned into noise. It's turned into static. And it's actually been drowning everything out. And I would argue all of this noise, all of this data actually starts to make it harder for us to make sense of what it means. There was an experiment done, and it came from the retail business or the retail industry, but it was an experiment done years ago where they had shoppers coming up and they gave them a choice. It said, here are two products. You can have product A, you can have product B, or you can not have anything. You choose to do nothing. And when given that choice between two products, 100% of the participants in this experiment chose one or the other. As they started expanding and they gave them more and more options, increasingly, the number of people who simply chose to do nothing rose until it reached a point where, given enough options, the majority of people would simply choose to not choose. And this is the problem that we have with noise, that when we have so much data, so many options, it actually leads to inaction. It actually leads us to not be able to make sense. We get paralyzed by all of this data. And in fact, it exposes one of the great fallacies. And this fallacy is that with more data, I get better insights. But I will argue that more data actually leads to fewer insights or to less insight. And the reason is the stuff that is meaningful, the stuff that's important, the stuff I can actually do something with gets buried. I lose sight of it. I can't find it. In fact, if you, as you might be able to tell by my Jerry Maguire reference, I'm a fan of movies. I actually once gave a speech in Australia where I was talking all about romantic comedies and how much I love them, and that's a story for another day. But I love movies in general. And if you are a fan of the legal drama version of them, and there's this, where there's a movie scene where, one of the legal teams finds that they have this piece of evidence that is going to destroy their case. But because of discovery rules, they have to share it with the other side. Well, what do? They go and get every box of every piece of information that they could possibly find, fill up a truck full of it, and ship it all over to the opposing counsel, to the opposing legal team, who then can't find this one piece of information that could help them win the case because it's buried in this mountain of data. I think that's what most IT operations teams are dealing with today. We have this thing that we thought was going to be the answer, all of this data, and we can't find the forest for the trees. Now, it's not like this has gone unnoticed. In fact, many technology vendors have recognized that this is a problem, and they have trotted out the answer. Here we go. We got the answer to this: machine learning. Machine learning to the rescue. It's going to solve all your problems. Just plug it in, out come the answers. All of your problems go away. In fact, again on the chat, if you're following along and want to play our game today, I would love to hear your favorite piece of machine learning hype. Just throw it in the chat, and I promise I won't quote you or use it, but I just would love to kind of see them because they're always my favorite. But there is so much hype around this that all we need to do is grab machine learning and throw it in there, and all of our problems go away. But if you have any experience going down this road, then you know the truth. And the truth is, it's just not that simple. In fact, it's nowhere near that simple, because the little piece of the puzzle, the little fly in this ointment, and by the way, I should go on record here. I'm a fan of machine learning and artificial intelligence, AI in general. I believe it is the future. It is, the promise of machine learning is real. But the hype that it's simple, that all you have to do is plug it in and turn it on, and it solves all the problems, that's the part that anyone who's spent any time at all inside of an IT ops organization knows that's not true. It just doesn't make sense. And the reason is this, is that it's, in order for machine learning to work, it's based on data. We need data, lots and lots of data. Now, the good news, speaking to the beginning of this conversation, is that IT organizations have lots of data. But it's not just data that machine learning models need. That data needs to be accurate and unfragmented. See if I can get that right. It needs to be a true representation of what reality is. And for a variety of reasons, maybe it's human-generated content, and we all know that us humans are the worst at entering accurate data. Or maybe it's the fact that as we ingest data, it starts getting disconnected. Or there's any number of reasons, but we end up with data that is less than accurate, and probably more importantly, is highly fragmented. So one of the other things you maybe don't know about me, if you don't know who I am, is that in addition to being a principal analyst with Intellyx, I've also written 3 books, and I write a somewhat regular column with CIO magazine. And I recently had the opportunity to interview a gentleman by the name of Diwakar Goel. He's the vice president and chief data officer with GE Digital. And for this article I was writing, and he gave me this great quote, which I think really sums this up. And he said, data ingestion is fundamentally destructive. That when you bring data into a data lake, so he was talking in a broader data lake context, but it's just as applicable when we're talking about IT data here, that when you bring that data in, you lose the relationships between the data sets. That it's the value of the data sets is less in the data and more in the relationships. And I think that is so critical. It is so key. It's not enough to just have data. It's not even enough to simply make it accurate. You need something else. And what you need can maybe best be described as context. And context is, I think, the real hero in this story, right? Because it allows us to start transforming that data into something that is no longer abstract, but that we can actually discern meaning from. It gives us the ability to translate it in the context, no pun intended, of what it is that we are actually trying to achieve, what we care about. And that's the most important part of this, is that data in and of itself has no value. It's not the data that's valuable. It's the objectives that we're trying to achieve. It's what we're trying to do with it. And so that context gives us both sides of that equation. It gives us both the ability to understand the relationships between the data and the how it all fits together, but also in the context of what we're trying to do with it, how we're trying to connect those dots. And I think the argument would therefore be that it's really, when we talk about context, it is what transforms it, right? It becomes the difference between data and insights. Now, I want to just take a second here and try to explain what this is, because it's, on the one hand, it's incredibly intuitive, right? It makes sense, right? I'm sure nobody is sitting here going, that guy's crazy. Well, who needs context, right? We use context every day in our everyday lives. We do it naturally. Our human brain is constantly creating contextual relationships, sorting them out, and is using that to help infuse kind of the way we see the world. So that statement is intuitive. But translating that, what does it actually mean, and why is it hard from a data perspective? Maybe isn't quite as right there for you. So actually, when I was speaking with the folks at ScienceLogic before we even were planning this webinar, they were kind of talking through this, and one of their executives explained it in a way that I thought was fabulous. And he said, imagine that you've been given this task of sorting out and creating a book catalog at a library, right? And the librarian comes and brings you this big box and says, hey, the good news is I have all the data for you. And he or she dumps it off into the floor. And as you look through all these little scraps of paper, what you find is on every piece of paper is one piece of little information. Maybe it's the title of the book, maybe it's the name of the author, maybe it's the publisher and the year it was published, but you don't necessarily know what any of it means. Now, given enough time and enough tenacity, you could take all those pieces and start sorting them out and go, well, that looks like it's probably a title. That looks like it's probably the name of a publisher, but what if the publisher's name is somebody's name, like it's an author's name, right? And so you could put it together, and it would take you a very long time, and a whole bunch of it's probably going to be wrong. If instead there was just one little change, that in addition to that piece of data, there was also a little piece of what we call in the world of IT metadata, data that described the data. So something that said, this is the name of an author. Oh, and this author wrote these books. So when you find these pieces of paper that have the names of these books, they are related. Suddenly, your process of forming this, of creating this catalog becomes much, much easier. But beyond that, it becomes much more accurate. It becomes meaningful. And that's when we talk about context, that's what we're talking about. And the good news is that it's, at least in my opinion, easy to understand. The not so good news is that for most organizations using traditional technologies, it is incredibly difficult to accomplish. Getting that context, creating that context is hard, which frankly is why most people haven't done it. It's why it's easier to collect the data, stick it in a big giant database and say, well, when we need it, we'll go look at it. And it's also why most people don't take action on data. I actually, my third book was all about using metrics to drive organizational change, to how do you help drive value in organizations using metrics. It was called performance-driven IT. And the core of that is that it all came down to connecting the metrics, the data you were collecting, with the outcomes you were trying to achieve. And that is the hard part. And it's why I when I was advising these large enterprise organizations, I remember this one time I went into an executive oversight board. So it was a bunch of senior execs, and they had presented this report. They'd come up with all these metrics and all this data, and they presented it and they said, thank you very much. And they walked out the door. And I was like, well, wait a minute. Why did you bother getting all that information if you weren't going to take action with it? But see, there was no insight there. It was just data. Why? It lacked context, both in terms of the relationships to each other and how did this relate to performance of either different environments or to some of the projects they were working on. It lacked that context, but it also lacked context to the outcomes they were trying to achieve. They couldn't make a decision because they didn't start out by deciding what kind of decision they were going to make. So I'm hoping I'm making the case that this context, the need to understand the data in relationship, is critical and is the bridge that turns that data into insights, and most importantly, into actionable insights that have meaning and have real value to an organization. So the question is, well, then what do you do with that? How do you create that? And Leslie's going to get into this a little bit deeper here in a little bit, but and you know, to a certain extent, this is obvious, but it's not easy, right? But there's really 3 steps. The first is that you need to go into this with recognizing that having data in and of itself isn't enough. That you have to be focused at the point of creation, the point of ingestion, the point of capture. You have to be focused on the quality of that data. And that means you need to actually put practices in place that are explicitly designed to help ensure that quality and to protect that quality. Now, some of that may be automated, some of that may be, again, it kind of depends on the source of the data, some of that may be policy, some of that may be automation enforced policy. But the point is that I think maybe it can simply boil down to this, is that you need to be consciously aware of data quality, and don't assume that simply collecting the data means I've got good data. Because, and again, you know, quote unquote good data or accurate data, it's somewhat in the eye of the beholder. You have to understand what accurate data means to you, but it's still about doing that consciously and deliberately. So that's step 1, and it's a whole set of practices around doing that. The second then is, it's not enough to then have good data, but I need to then create context. I need to enrich it with context. And this is fundamentally about establishing the relationships between the different elements of your data sets, right? And so I've kind of beaten this horse a little bit, so I'm not going to spend too much more time, but it is, again, a discernible step that you have to actively look to create that context. And then the last thing is what I was just talking about, that you have to then make sure you're orchestrating all of this in the context of the outcomes you hope to achieve. If you don't know what you're going to do with this data, if you don't know how it's going to transform the way you operate and manage your IT technology stack, then what are you going to do with it? It's not going to be useful. It's not going to make any sense. Now, sometimes at this point, I will be having a conversation, maybe having a glass of wine with somebody and kind of going off on one of my little, you know, tirades about why this is also necessary. And the question is, well, how do we used to do this? Why is this really a new problem? And here's the thing, it is, see, because the way we used to solve this was standardize and rationalize. That we would go and bring on all these new technologies, and if you've been around a while, you would live through these cycles every 1 to 3 years, where we'd go and collect all this stuff and we'd go, wait a minute, we have too many, it's too complex, too hard to manage. We're going to go rationalize it down. We're going to pick one and we're going to standardize on it and go through this process. I think the thing that has fundamentally changed is that, in my opinion, is no longer an option. And in fact, I've actually written a little bit about the fact that I think complexity in this sort of ironic way is becoming a source of competitive value for organizations, or more specifically, those organizations that can have an incredibly complex technology stack, complex operating model, complex business model, but still manage it effectively and efficiently and deliver it consistently and resiliently are the organizations that win. Because if I standardize and rationalize today, I'm almost certainly going to not be able to meet the very specific, nuanced, customer-driven needs of some constituency, whether that's my customer themselves or a business unit that needs that complexity to be able to have this kind of customized solution to deliver to their customers. And so I don't think we're ever going to go back to this simpler time. I think complexity is the new normal. And so the question then is, well, if this is our complex future, how do we manage that, right? If we're trying to create this good set of data quality and we're trying to create context and we're trying to be focused on outcomes, how do we actually achieve that? And I think the answer is that we need this idea of a common data model, this common approach to how we treat all this data. It's sort of like going back to that example with the book catalog and having all these pieces of paper. If we define what each of those pieces of paper look like, then we know what to do with it. And that is the trick. And it's this, on the one hand, a simple trick, right? And it's something, by the way, in the world of big data, in the world of other, the data-centric elements within other parts of the business that they have recognized a long time ago, that the common data model is the way that you can simplify the complexity without eliminating the complexity. It gives you a mechanism by which to manage it without destroying it. And so that is the answer. And I know Leslie's going to talk a little bit more about that piece of it. But I think that it's what I'm hoping that you are taking from this is that we've got a real challenge out there, and the stakes are only getting higher. And so it's about not lamenting it or trying to rationalize it away, but it's about trying to find the pathway that leads you into this future in which effectively you can do it all, where you can have all of this complexity, but still manage it effectively. And I think, having been an ops guy, that can seem scary. I joke that, it would be a tough job today. 20 years ago, I joked that we used, we had NTR architectures, but that N had a single digit in it. Today, these complex environments are almost indecipherable. And it's why we're going to need machine learning and AI technologies to make sense of it, because we're rapidly reaching the point. In fact, I think in many cases, in many organizations, we're already past the point where no one person can actually understand all of this. So we have to use technology to collect all this data and to make sense of it. But I will also say that I think that this is, in addition to being maybe a little frightening, an amazing time to be in IT operations. So if you follow my work at all, the core of my work is all about digital transformation. And digital transformation is really about business model transformation and the shift in power to the customer. And you can read my stuff if you want to kind of know my perspective on all that. But here's what we're seeing, is that that's all true. But there's this connective tissue that at some point you can do some of that on the edge. But at some point, it comes all the way back to your ability to operate at scale, the ability of the IT organization to handle this complexity. And I really believe that the organizations that are successful at digital transformation are going to find that at their core, they had an IT operations team that was brave enough to transform themselves at the core and effectively become the engine of broader business and digital transformation. And so that's where I think each of you are sitting at right now with this tremendous opportunity in front of you. You just have to be ready to go for it. So I hope you do that, and I hope Leslie is going to enlighten you a little bit more of how they're approaching it, and it's really cool, exciting stuff. So with that, Leslie, back to you.
All right, great. Thanks, Charles. So now that we've talked, I think Charles has talked extensively about the importance of context. We're basically going to talk a little bit now about how that context can be used to transform IT operations, to simplify the complexity and basically make it possible for IT to become a true enabler of business value. So there's this idea, this industry perspective, if you want to call it that, of what AI ops is, and I think Charles already alluded to this, that most people think of AI ops as simply big data plus AI or machine learning. You apply the AI or the machine learning on tops of all this data, gobs and gobs of data, and magically you're going to be able to drive automation. And, industry analysts like Gartner are predicting that there's going to be a significant increase in the adoption of AI ops by the year 2023. I mean, right now there's probably under 10% that are actively pursuing these approaches, and that number is growing dramatically. But at ScienceLogic, we believe and we agree with Charles in the assessment, and we've been collaborating for a while now on this idea that throwing a bunch of data together and applying analytics on it's just simply not going to work. Why? Because there what we believe are three missing ingredients. The first is real-time, clean, accurate data. Second, real-time context. And third, automation, because the end goal of AI ops is all about automation. But in reality, few organizations, if any, and I imagine most of you on this call today would admit that they're not likely to automate if they don't trust the data. If they don't believe that the data quality is good enough, they're not going to automate. And if they don't understand what the impact is, if they don't understand those relationships between the data points, they're not going to automate. So today we're focusing in on context, which relies on clean data. I'm not going to spend a ton of time talking about the clean data, but that clean data with context is ultimately what's going to allow you to drive automation. And that's really what AI ops is all about. So when you think about these challenges, the challenges is that, first off, bad data can compromise your implementation. So if you just throw a ton of data together, you're going to end up with bad data, and bad data is data that hasn't been cleaned. It's not standardized. It hasn't been deduplicated. It's not organized in any way, shape, or form. It's like a data swamp. You throw everything together into the swamp, it just gets bigger and bigger. You could think of it like the kitchen sink. There's no organization, there's no structure. You really don't understand how it all works together. And it becomes very costly and time consuming to use. Now, according to Gartner, 79% of time being spent by folks that are actually looking at these technologies today, looking at AI, looking at machine learning, they're spending 79% of their time collecting the data, just trying to get the data, cleaning it up, fixing, the holes, the missing pieces, filling in the gaps, making sure that it's standardized and consistent format, and then putting it into some organizational structure, into, having that context, that relationship. So what people want, what you're aiming for, is good, clean data. Data that's clean, it's consistent, it's complete, there's no missing pieces, and it's all grouped logically. And all that will allow you to improve the time and cost it takes to leverage that data, because without that good, clean data to begin with, you don't have the ability to start to build context around it and then start to do automation off that data. The second piece that's missing is modern data lakes today are missing that context. They contain a bunch of data from a variety of sources, and yet there is no relationship between those technologies, between the applications, between the business services. It's all unknown. Sometimes there's pockets of relational data, but you really don't have the full picture. There's no linkage between all of these piece parts. So if you think about Facebook is known for creating relationships, and context is a huge factor in its success. Facebook is combining blog sites, they're combining photo sites, email interactions, video sites, and tons more, right? I'm not actually a huge Facebook person myself, but I've seen the value, and my kids have certainly seen the value in connecting all this information together. And what it does is they've provided this complete view of all your interactions within Facebook and within these different pieces of technology that are out on the internet, so that they can start to build really smart recommendations. Oh, if you watch that video, perhaps you might want to see this, or you might want to buy this. And they've built a whole business around this relational context that they've derived based on whether or not you watch or friend or like or listen to different assets within their environment. Well, like Facebook, ScienceLogic is providing one place where you can see and manage all the interactions in your IT environment. And to do this, we are mapping and tracking relationships across all the technologies and applications in a business service. We're connecting your business services to the applications, and we're then connecting the infrastructure to itself and the infrastructure to the applications. And with that knowledge, we're able to then start to relate the performance, the faults, the failures, the configuration information, and other data from all these different sources, so that you can understand what the impact is when something happens. And with that context, we can start to provide better recommendations to further automation. So, we're basically providing this good, clean data with context in real time. So I'm gonna give you an analogy. I know Charles gave you quite a few, but you think about, we all probably, unless you're not big on driving yourself and you're Ubering everywhere, when you drive your car every day, you have a dashboard. And that dashboard is constantly telling you how fast you're driving your car. And while that is a useful piece of information, it's not sufficient, because without knowing where you're driving that car, are you driving through a school zone? Are you driving on a highway? You don't understand if the speed that you're driving is too fast or too slow. You don't understand that impact. So having this contextual information that we're able to provide about how the infrastructure components work together, how they affect the application, how the application parts work together, and how they affect the business service is really what we refer to as the secret sauce that ScienceLogic provides. We're not only bringing the data together, but we're adding that context to it. So foundationally, when you're looking at ScienceLogic, we take data from all these different data sources. We don't care whether it's cloud, whether it's application, it's log data, it's infrastructure, network. It could even be data coming from a service management solution like a service desk or a CMDB. We can essentially take data from anywhere anything that can communicate on the network. We apply a number of different methodologies. You can see these different collection methodologies here to feed that data in real time into a data lake, so that you can actually see what you have in your environment. And there are examples here. I mean, I could highlight. We bring data from satellites, satellite systems that are unique to Hughes satellites. We can monitor technology on the International Space Station that was not, it's certainly not standard. It was not developed within the US. We also can monitor things like streetlights. So it's not limited to just the IT infrastructure. If we can access a device or on the network, we can bring that data in using any one or any combination of these techniques to bring that data in and put it into a data lake. We then apply context to that data to make it more meaningful and actionable. We're deriving that information, applying machine learning techniques to understand at the edge what is related to what is calling what is communicating with what, and what has metadata relational information that we can use to derive those relationships in an automated fashion to make that data more meaningful and actionable. And that allows you to further apply machine learning and analytical techniques to drive automations, to be able to do things like automatically detect anomalies or predict future issues, to be able to assess the impact on a business service, to even initiate resolution or repair, or to enrich incidents with additional diagnostic information. So these are just examples of the kinds of automations that can be driven off of this contextualized data that can reduce the amount of time and effort you're spending collecting the data yourself, understanding it, building automations off of it yourself, because all of this stuff can be done in a more automated and consistent fashion. So to summarize here, and we're not going to get into, given the time frame that we have, we don't have time to show a demo. We'd love to have the opportunity to show you more about how the product works, how the platform works, and how it can help. But to capitalize on what we've talked about today, if you're looking to transform IT operations with machine learning, our automation engine for AI ops lets you see everything you have in your IT environment, make sense of it with context, and do more with it through automation. And that's all done in one platform. We're not talking about multiple products here. It's a single solution that allows you to do all of this across all of your IT environment, whether it's network, compute, storage, cloud, you name it, it can be done within the single automation engine for AI ops. So with that, I'd like to turn it back over to Charlene. I think we want to open it up for Q&A at this point.
Yeah, absolutely. If you have a question for either of our panelists, please go ahead and use your GoToWebinar control panel. We're going to go ahead and start diving into the questions. The first one is, what types of context are needed?
Yeah, well, let me start with that. I think it's sort of like when I was working on my first book, I had this question like, well, how long should it be? And the sagest advice I got was, as long as it takes to get your message across and not one word more. And I think context is sort of the same way, right? It needs to be focused first and foremost around what are those outcomes you're trying to achieve, and therefore what contextual understanding do you need to have it. I think there's some practical answers there as well, but I think that what I'd like to add to the conversation as a starting point is a logical one. Is it, if you start with a technical question, you're going to get a technical answer. So I think understanding the need for context, the most important first step is to put it in a business or a business value context. I keep using this word, but in that connotation, right? To understand it from that perspective and let that drive the rest. And then, from a technical standpoint, I don't know, Leslie, you want to chime in on the different, how you guys see it at a technical level, the context relationships?
Sure. Yeah. So we look at it as like there's really four basic forms of context. The first is, fundamentally is the infrastructure, understanding how all the infrastructure components work together. So as an example, if you're using VMware in your environment, it's not sufficient to look at individual VMs. You're going to want to understand how those VMs combine together within, with their relationship to an ESX host, so that you could be moving VMs around, you could be understanding how many are running on that host, so that maybe it's oversubscribed and you need to move things to another. You also want to understand, all the way down to the bare metal, like what the relationships are. So from an infrastructure perspective, we're talking about that that kind of relationship, and not only between the VMware, but also between the storage and the communications to the network. Then you want to be able to add the application perspective on it. So you want to understand the application components that are running on this infrastructure. So you need to understand the pieces of the app. Then you need to understand, of those app pieces, which ones are connected to that infrastructure. So again, you could be spinning up applications in various containers and in using serverless technologies. You could be spinning them up in the virtual machines on the cloud. They're all over the place, and you want to understand how they're connected. And I'll give you an example here of recently we were working with a customer in a financial institution, and they'd been using an APM solution that could give them the application perspective. And they were experiencing a problem. It was costing them on an average of $50,000 an hour for, a minute for downtime. $50,000 a minute. Couldn't find the problem. We actually went in and installed our product and connected the dots between all the infrastructure, because we monitor all of it, not just the infrastructure that the application sits on, but the infrastructure that's shared across multiple applications. We were able to identify a problem in the infrastructure. It happened to be something related to the network that was affecting the speed, the response time of the application. They didn't have that visibility through the APM tool by itself. So we were able to actually integrate with the APM tool, bring in their data, and identify the relationship from the app to infrastructure. The fourth area is business services. So if you've got multiple applications that comprise a business service, you need to be able to understand, again, how those different applications, some of them could be cloud or SaaS-based applications. Some of them could be running on-prem. So you need to be able to connect those pieces together as well. So it's really those four areas of contextual relationship data that we're able to bring to bear to help organizations.
Okay, great. We have a question actually that just came in that is very relative to this, which is, what is the best approach to determine a context?
That's a very, very good question again. So what I would say is that there are different ways. Okay, I wouldn't, and our approach is a multi-pronged, as I showed on the slide there. We have different techniques for collecting data. And when we're collecting data, we're collecting metadata about the data, about the devices or the components that we're looking for, we're discovering. So it's about having the data available to us, but it's also about understanding communications that are occurring. So we use a combination of approaches to understand when calls might be made from one server to another, for example, so we can understand a communication that is occurring between things. We also can leverage context that may be provided to us by the technology itself. So that, I use the VMware environment again, but many, it's not just VMware, but, AWS, Azure, all of these vendors that are producing technology today are providing APIs that give us access to information about how that technology works. And as that technology is becoming more software defined, having all that the relational information, the contextual information to understand how that technology works within itself, we can pull that information in as well. So it's a combination of you can add metadata. Perhaps you're using tagging or you're adding attributes where you're configuring. You have naming conventions. You could be using, again, the APIs to pull it from the source technology. And then it's also communications that are occurring across the network as these things are talking to each other and communicating with one another. And we leverage all of those in terms of determining context. So it really is a combinational approach.
Well, and let me just dive in on this a little bit and maybe give a very blunt, straight answer to this, and that is that I don't think it's possible for a human today to actually establish every contextual relationship. I believe you can only do this through automation. It is just too complex. And so, it is about having to use these tools. And here's the thing, I mean, as much as I said that we as humans naturally infer contextual relationships, which we do it somewhat subconsciously. When you ask someone to do it consciously, they inevitably miss huge elements of a relationship. And the good news is that, historically, when we were looking at business processes, the challenge that we had is that they were disjointed systems. That you'd have, the system over here that did some part of a business process, but didn't touch another system that did some other part of it. And there was, maybe someone manually moving a piece of paper between the two processes or something. Today, with everything being digitized, you have tools, like ScienceLogic that now suddenly can expose all of those relationships that can in fact infer them in a way that we can't do. So while Leslie's kind of talking about all the technical elements, the big thing here is that I don't believe you can do this any other way, meaning it has to be some form of an automated fashion to look at the data flows themselves, to look at the interactions. And inevitably when you do this, and Leslie, you can speak to this, but I'm sure that when you show this to your customers and when you go through this process, they inevitably find relationships that they did not know existed. And so that's the kind of context that you need, because those are the ones that get you.
Absolutely, and I can't agree with Charles more on this. That it is really about the ability to automate as much of the contextualization as possible. And there are going to be cases where it can't be fully automated. I mean, the machine learning and AI capabilities are not going to know, what your business service is without some guidance, some baseline for defining what the service is. But once it has that initial set of information, it can leverage information that has been captured in a more automated fashion. And I would also, add to this that the fact is that applications and business services and even just the core infrastructure there's so many more moving piece parts. There's so much more complexity. And Charles touched on this early. It is not humanly possible for anyone to know how all of this works together today. It's just you can't keep up with it because it's changing all the time. And I will say that we've had numerous customers where we've gone in and we're showing them information just in the discovery process, just in the basic, what do you have in your environment? We go out and we've discovered in some cases tens of thousands of things that are running in their environment that they weren't aware that were there. And we've been able to actually help them, eliminate and repurpose resources that are no longer being used, that are no longer needed. In other cases, it's just optimizing information or understanding that the complexity of their environment is just way more complex than they ever imagined before. So there are numerous examples of customers that we've run up against that. And again, I would mention one of our customers very recently found out that there was a whole cloud based environment that had been deployed and had been sitting and they'd been paying for months that they were basically wasting money on. Had they not used our solution to identify those resources, they would have been sitting out there. Somebody had spun something up, had tested it out, and had completely forgotten it. And so we were able to recoup, the costs that they were spending in that environment for something that was no longer needed.
A renegade cloud instance? I don't believe it.
Yeah, that never happens.
Of course not.
Okay. All right. So real quickly, one of the audience members asked the 4 different approaches that your company does context. And you said infrastructure, app to infrastructure, and business analytics, correct?
Business services.
Business services. Okay. All right. Great. So I hope that answers Jeannie's question. Okay. The next question is, let's see, is transient data also important as contextual data? And by transient, I mean data that is collected, say, during a process and operation and need not be retained.
Well, so I'm curious. I actually don't know how ScienceLogic handles this. So I'm curious to hear Leslie's take on that. But in broad strokes, the answer is absolutely yes. And in a very just a simple non-IT example, right? If we think of a autonomous vehicle, there is a massive amount of data that has to be consumed and contextualized in order to operate. And this is mostly in the operation and the operationalization of machine learning models or AI. But I'm going to discard 99% of that data and only send a fraction of it back into the cloud for improvement of the model and for analytics and other uses. But I'm going to discard that. But that doesn't mean that in that moment of time that contextualization isn't vital. In fact, it is critical. And I think if you translate this into an IT operations environment, the same things happen as you're looking at automation. You still need to establish that common data model, which gives you a reference point to process. And I'm not sure if you're talking like streaming IoT data, but there's lots of different forms of this kind of transient data that I may in fact discard, but having that contextual understanding allows me to act on it. So Leslie, I'm curious, how is ScienceLogic approaching it?
Sure. Yeah. So absolutely, we do feel that it's important to be able to collect some of that transient data. And to Charles's point, the expectation is that you're not going to store it all because you'd eventually, run out of storage. But it is important, and this goes back to his point earlier about understanding what your business objectives or what your ultimate goal is with using this information. So we've been doing a ton of work with Cisco, both their internal IT as well as their managed services, and we've worked very closely with them to identify what data to actually collect, because they're trying to automate processes to remediate problems. So collecting certain information enables them at the time that something is instantiated. We're collecting that information, and that information can be useful in determining when a problem occurs, or in determining what next steps should happen when a problem occurs. So we're collecting information, discarding the things that they don't feel is important, so you can configure the system to collect whichever sets of data you want. You're not required to collect it all, and we don't expect you to. But that information then can be attached to the events that are being generated. It could be attached to incidents that are created within your service desk, and that information can be incredibly useful when you're trying to figure out what needs to be done, whether it's in a completely automated or a partially automated repair or remediation activity.
All right, great. Guys, we have about 5 more minutes. If you have a question for either Charlie or Leslie, if you want to go ahead and send it on in, we do have time for 1 or 2 more questions. Let's see, the next question. In your experience, is noise a real issue?
Oh, well, I'll take the first. Well, hopefully the answer is obviously yes. Just for maybe some color commentary on it, I was working not too long ago, just a few years ago, with a very large financial services company in the Midwest, and sitting down with their head. I forgot what his exact title was, but basically he was just lamenting to me how hard. And by the way, I think they are one of the best run IT organizations I've ever come across. But going to my point that it's just almost impossible for even very capable, well-intentioned humans to make sense of the amount of data that we're dealing with and the amount of complexity we're dealing with, that he was just lamenting how much trouble and how much time and energy his team was spending just trying to deal, I mean, this whole term of alert storms, right? Just dealing with that, just trying to sort through and to figure out, and I think the big challenge here is when we talk about noise or static, what we're really saying is everyone knows that they need to find that piece of information that actually means something, right? Any of us that have lived this, we know, we see this alert and it's like, yeah, that's nothing, because we know it. And, you know, but until recently, there haven't been systems that were intelligent to know it too. And so we have to sit there and, you know, click, close, 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 delete, delete, delete. And so it becomes this real significant issue. And I think, you know, while I know we're not talking about security per se here, I'm a big believer that we're going to see in the very relatively near future a much closer or a much more of a merge between IT operations, security operations. And part of the reason is, in fact, this noise problem. Is that if you look at most of the breaches that have occurred from a security standpoint, it's not because they didn't know it was there or they completely missed it. In most cases, it's the handoffs. And the reason the handoffs fail is because they got handed off in the midst of all of this noise, and they couldn't identify the relative importance of what was happening. And so I think we're seeing example after example after example. You're seeing the same thing when you see change failures occur and whole systems go down because someone made an innocuous change. Effectively, it's the same story. It's the same issue about not having enough context of those relationships to understand the impact of that change or of anything that is going to happen with it. So, you know, I'll let Leslie answer from a ScienceLogic perspective, but you know, I think this is as real as it gets.
Yes, yes, and I would close with an example. We were working with a company, it was a food manufacturer, and they basically were experiencing a lot of issues, you know, like most organizations. And they first went down the path of like, we can only, you know, we have a staff of 40 people and we're only able to handle, you know, a couple thousand incidents a month, because of the volume of incidents that they were having to manually create. So first we helped them automate the incident creation process. So we automated when something went wrong, we automatically create the ticket and we started to put information into it. So we took that burden off of them. Then what they found is, oh, well, now we realize that we have, you know, 2 or 3 times as many issues occurring that were now being automatically created in the ticketing system, in the service desk, than they ever even imagined, because they were never creating those tickets before, because they were spending all their time, you know, manually creating them. They weren't even getting to them. So we incrementally were able to address the noise by eliminating, you know, the noisy symptomatic events through context, right? By understanding that these are related symptomatic issues, alerts that we're firing, we were able to reduce the noise in that way. We were able to reduce the noise in terms of the number of incidents that were driven off of that. And then being able to eliminate noise in terms of all the data that is out in the environment. By collecting information when a problem occurs, we're able to collect the relevant diagnostic information. So if you think about log data, you have a tremendous amount of data in your logs being collected all the time. What we focus on and what we're able to help customers do is start to pull in that information that is relevant to the problem or to the processes that are going on or happening at the time that a problem occurs, so that you're not going in and trying to look through an entire log file or a set of log information to find what you need. We're giving you that context that here's the part of the log that you care about that's related to this event, that's related to this particular application or service that was affected by that infrastructure. So again, it's tying that context all the way through the process to help you eliminate noise at many levels within the IT environment. So the contextual information is really critical to helping you eliminate the noise, which is just getting worse and worse as we produce more and more data faster and faster. So.
Oh, All right, great. Well, we are at 2 minutes to the top of the hour, so unfortunately that is all the time that we have for questions. I do want to thank everybody who did send in a question. Please know that if we did not get to your questions, the folks over at ScienceLogic will be getting a copy of all of the questions, and I'm sure somebody will be more than happy to follow up with you offline. Also want to remind the audience that today's event has been recorded. So if you missed any or all of it, or if you just want to listen to it again, you'll be able to access the webinar on demand. We are going to be sending out an email that contains a link to the webinar. You should be receiving it in your inbox shortly. The webinar is also going to be living on the devops.com website. So if you have any problems with the link, or you just scroll around the devops.com website, just check the webinar section under on demand and it should be right there waiting for you. While you're there, go ahead and take a look at the other webinars that we have, both upcoming and on demand. We have a ton of them, folks, so hopefully there'll be one or two more that pique your interest. Charlie and Leslie, both of you, thank you so much for giving such a great presentation. Tons of great information in here, so I appreciate it. I'm sure the audience did as well.
All
Thank
right.
you.
Thank you, Charlene. Thanks,
Great.
Charles.
Also want to thank the audience for joining me today. I'm Charlene O'Hanlon and I'm signing off. Have a great day, everybody.